Okay, so now we move over to how to determine shifting of the reciprocal function. And I put an example here that you have seen before. So we already know how to work with that. Remember, this is a parabola. This is not what we're doing now, but this is just a review of what we've done before. So with a parabola, we figure out what the shifting is. Remember that this -5 tells me that the function goes down 5. This 2, remember, is always the opposite. So instead of it going right 2, which is the positive direction, it goes left 2. It goes in the opposite direction. So left 2 for that 2. And this 4 tells me that it goes 4 times faster up. So it goes up 4 times faster. Okay. So when we look at that, we can see that the normal parent function for a parabola, would look something like that. And then in this particular case, this is going to shift down 2, left 2, down 5. So 1, 2, 3, 4, 5, 1, 2. So it's going to, the vertex is going to be there, and it's going to go up a lot faster. So it's going to go up pretty fast. And that's a sketch. So we can kind of have a general idea of what the sketch looks like. Here's the parent function. Here's the new function. Okay, so what does that mean about the reciprocal function? Well, notice that we have f of x equals a over x minus h plus k. Here in this case, there's our a, there's our h, there's our k value. Remember that the k causes it to go up or down. If it's positive, it goes up. If it's negative, it goes down. The h causes it to go left or right. And remember, we're always doing the opposite. So if we have x plus h, that means it goes to the left or to the negative direction. If we have minus h, it goes to the right or to the positive direction. And then this a tells me, well, it goes up faster if it's greater than 1. It goes up slower if it's somewhere between 0 and 1. So if it's a fraction and it's not greater than 1, it's going to do vertical compression, which means it's going to stretch out a little bit. If it is greater than 1, and notice we have an absolute value there because it doesn't matter whether it's positive or negative, it's going to do that. Now, if it's a negative, remember, then it shifts if the a is negative. So if we have a negative a, remember that it shifts over the horizontal asymptote. So we'd have our horizontal asymptote and it would shift over. So if it's doing something like that, it would shift over and do something like that. Okay, so we're going to graph some things now. So we're going to do a few graphing things, and then we're going to check them on Desmos. So what I want you to really understand, not necessarily is how to graph them, and I know what they say graph, but have a general idea of the sketch. So what it's going to kind of look like. So notice here my a is equal to 1. Okay, it's negative, so that tells me it shifts over the horizontal asymptote. This plus 4 tells me it goes up 4. And this x in here, because there's no number there, that tells me it does not shift left or right. Okay, so we can kind of have a general idea of what it looks like. A is equal to 1, so it goes up normally. Notice that it goes up 4, 1, 2, 3, 4. So if it goes up 4, that means the asymptote has moved up 4 from the horizontal axes. Notice here it does shift over the horizontal, so I'm going to kind of sketch out the normal one. I'm going to sketch it out in red, so we can see that, it kind of looks like that, and it kind of looks like that, right? So that's and if we're looking at the parent function, I think that's what the parent function looks like. Did I get that backwards? I might have. No, I didn't. So that's what the parent function is going to look like without it shifting over the horizontal. But because it shifts over the horizontal, we're going to draw it in blue. The actual function is going to, and notice it doesn't go up any faster. So it's going to look something like that. and it's going to look something like that. So the blue drawing is what it's going to look like. Now what we do is after you guess what the sketch looks like, we're going to check and see, are we right? So -1 over x plus 4, so we're going to go over to Desmos. We're going to type in f of x equals, we do -1 divided by x plus 4. And notice what it does here. We're going to kind of move that down. Notice that we said it looks like this and like this. We have a general idea of what the sketch looks like. And we can see that, pretty good guess. That's what I want you to do. Okay, so for this one now, we can figure out, okay, how does it move around on this one? Well, it goes down 6. It goes left 5. And it shifts over the horizontal axes. Now, how do we know if it's horizontal or vertical? Well, if the negative is here, it shifts over the horizontal. If I have a negative in front of the x, it shifts over the vertical. Okay, so then we're going to kind of draw the sketch. Again, it goes down 6, so 1, 2, 3, 4, 5, 6. So I can see that my horizontal goes there, but then it also shifts to the left 5. 1, 2, 3, 4, 5. So my vertical axis is there. So notice that my center point, in a sense, is sitting right there. Okay, so now let's draw the parent function. So the parent function we're going to draw in red, or whatever color that is. And so the parent function is going to look something like that. And now it's going to shift over the horizontal. So that means if I were to draw it in blue, it should look something like that. Oops, didn't draw it very well. Okay, and down like that. So we can kind of see where it is. Notice here at this point, which is located at -5, -6, is where that center point is. So we're going to go ahead and type this in, f of x -1, x plus 5 over. So it's kind of the same thing that this looks like. I'm going to go ahead and erase this. So I have -1, not 10, -1 divided by x plus 5 minus 6. We're going to go ahead and squeeze out a little bit. Notice it never crosses this -6 line. It never crosses this -5 line, so that my center point is located right here, which is correct. Notice how it's on these two sides. We're going to go ahead and look at that and see that in blue, we have it. Oops, I drew this over here. So I made a mistake over here, and that's what kind of gives me a good idea as to what happened. Is I can go in and I'm going to mark it. I'm going to put an X there to say that that's not right, and it should have been all the way over here. Okay, but that's how you kind of figure things out. But I was pretty close, not exact. Of course, you wouldn't have the right points if you were close, but you would have a good number of the points. So that's what you want to do when you're doing these problems, is kind of guesstimating and checking yourself, but that should help you with some of the corrections. And now I'll remember to not make that mistake again. Okay, so we're going to be done there. We're going to come back and we're going to do a couple more problems.